Dear friends, welcome to the next problem of gears, that is problem number 50. The data of the problem is like this. Two 20-degree full depth involutes per gears having 30 and 48 teeth are in mesh. The pinion rotates at 840 rpm. The module is 4 mm. Find the sliding velocities at the engagement and at the disengagement of a pair of teeth and the contact ratio. If the interference is just avoided, find 1. The addenda on wheel and pinion. 2. The path of contact. 3. The maximum velocity of sliding at engagement and at disengagement of a pair of teeth and contact ratio. Friends, let us note down the given information. Here it has been given the pressure angle is 20 degree, number of teeth of pinion is 30, number of teeth of gear is 48, speed of pinion is given 840 rpm, module is given 4 mm, and we have to find out the maximum addendum of gear, maximum addendum of pinion, path of contact, maximum sliding velocity at the time of engagement of the pair of teeth, and maximum sliding velocity at the time of disengagement of pair of teeth and contact ratio. Here it is given that the interference is just avoided, means the addenda are maximum, and we know that the maximum addendum for gear is given by this relation, where G is nothing but a gear ratio, that is ratio of number of teeth of gear to the number of teeth of pinion, and that is equal to 1.6. So the reciprocal of gear ratio 1 upon G is equal to 0.625. Substituting these values, we found maximum addendum of gear on calculation is equal to 8.8 millimeter. We also know that the maximum addendum of pinion is given by AP max with this relation, and upon substitution of values, we found on calculation that maximum addendum of pinion is 17.62 millimeter. Now, path of contact is given by path of approach plus path of recess. Let us say relation 1. And the equation for path of approach is given by this relation. Let us say it is number 2, where R is pitch circle radius of gear given by m into number of teeth of gear by 2, and on calculation we found pitch circle radius of gear capital R is 96 mm, and capital RA is addendum circle radius of gear, that is R plus addendum of the gear. So we found on calculation RA is equal to 104.8 millimeter. Substituting these values in relation to, we found path of approach, and on calculation it gives the magnitude is equal to 20.50 millimeter. And we also know that the path of recess is given by this relation. Let us say it is number 3. Again, here small r is pitch circle radius of P1, pinion, that is given by mt by 2. On calculation, it's found 60 mm, and Ra is addendum circle radius of pinion given by r plus ab max, and on calculation we found it is equal to 77.62 millimeter. Substituting these values in relation 3, we found path of approach, path of recess is equal to, on calculation, is 32.82 millimeter. So using relation 1, path of contact will be equal to addition of path of approach plus path of recess, and it gives 53.32 millimeter. Now, maximum sliding velocity at engagement is given by this relation, that is omega p plus omega g into path of approach. Let us say relation 4, where omega p is angular velocity of pinion and omega g is angular velocity of gear. We know that ratio of speed of gear to pinion is given by ratio of number of teeth of pinion to number of teeth of gear. So, we found number of teeth of gear is equal to this relation, and on substitution of different values and on calculation we found speed of gear ng is equal to 525 rpm. Now omega p is equal to 2 pi rpm of pinion divided by 60. Substituting the values, we found omega p is 87.96 radian per second. Similarly, omega g is given by 2 pi ng by 60, and substituting the different values, it's calculated 54.98 radian per second. So, using relation 4, maximum sliding velocity at engagement is given by omega p plus omega g into path of approach, that is 2930 millimeter per second. So, maximum sliding velocity at the engagement of the teeth pair is 2.93 meter per second. Now, maximum sliding velocity at disengagement, and it is given by the relation omega p plus omega g into path of recess. Substituting these values, omega p, omega g and path of recess, it is found that sliding velocity maximum when disengagement is there, it is 4691 millimeter per second. So, the maximum sliding velocity while disengagement of pair of teeth is 4.691 meter per second. Now, we know that contact ratio is given by arc of contact divided by pitch. Let us say relation number 5. And arc of contact is nothing but ratio of path of contact to cos phi. Substituting this value and on calculation, we found arc of contact is equal to 56.742 millimeter. Now, using relation 5, the contact ratio is given by this arc of contact divided by pitch, that is 56.742 upon pitch is nothing but pi into module. On substitution of values and calculation, we found contact ratio is equal to 4.51. So, we can conclude that The addendum of the gear is 8.8 millimeter. The addendum of the pinion is 17.62 millimeter. The path of contact is 53.32 millimeter. Maximum sliding velocity at engagement is 2.93 meter per second. Maximum sliding velocity at disengagement is 4.691 meter per second and contact ratio is 4.51. Thank you friends, and you are most welcome. If you have any confusion or query or any other problem, please write into comment. I will reply. Thank you again.